There is a result in mathematics that tells us that if we're adding up a sum of numbers such as this, uh, 1/2 plus 1/4 plus 1/8 plus 1/16 and so on, and we keep going, doubling the denominator with each successive term, that sum equals 1. Um, and that, in fact, it's part of a more general result, and which you can investigate by using a basic program. But first thing I want you to do is I want you to write a basic program that computes this sum, 1/2 plus 1/4 plus 1/8 plus 1/16, and we'll go out so many terms and stop. We certainly aren't going to add an infinite number of terms, so we go out so many terms and stop and see what that sum sums to. And then we might investigate looking at sums such as 1/3 plus 1/9 plus 1/27th, and so on, like this, and see what happens, okay? So with this, let's look at how we can do a basic program to do that. So let me uh, investigate that. I have a basic program here written out which does that, but because I did it while I was getting ready for this, Chipmunk Basic. So let me start all over again with this program. And I'll do that by closing Chipmunk Basic, quit, and opening up a new window so you can follow along with me as I write this program out. Okay, I'm going to begin with statement 10, and statement 10 will be the first input value. I will input the value of x. Let me input, let me put it in quotes. The value of x equals, close quotation marks, comma, x. So that inputs x. So x will be the number that appears right here. This would be x equal 2. This would be x equal 3. Okay, so x equal 2, we have 1/2 plus 1/4 plus 1/8 and so on. Then I'll input the number of terms in the sum, 20, input, quote, the number of terms in the sum equals, close quotation, comma, n. Now I'm going to run through a for loop. Okay, now I began my for loop, which is going to sum up a bunch of numbers, by setting sum equal to 0.0. Now, I put 0.0 so the computer knows that I'm using real numbers and not integers. So I indicate that by putting in a decimal point. Now I put in my for loop, 40, for I equals 1 to n. So I'm going through n terms in the sum. I set 50, sum equals sum plus 1 divided by x to the I. There, oh, that's not what I wanted, uppercase caret to the I. Okay, sum equals sum plus x to the I. Then I do 60, next I. So what this sum will do is it'll go through, we said we wanted n terms in the sum, so it goes through these n terms, and it adds up each term. This would be 1 over, this would be, if x is equal to 2, this would be 1/2. Then when I is equal to 1, then when I is equal to 2, it's 1/4. And then when I is equal to 3, it's 1/8. So it's 1 over x to the I power, next I, and then 70. All right, print. And I'm going to print the value of the sum is equal, close parentheses, comma, sum. So let's list that program, list. So here I have input the value of x equals, input the value of x, input the number of terms in the sum, input m, then I evaluate the sum, and then I print the value of the sum. Let's see if it runs. Value of x is pick equal 2. Number of terms in the sum is, let's pick 10. And as you see, it almost sums exactly to 1. As I put more and more terms, this will get closer to 1 until we reach the limit of accuracy on the computer. Now let me try picking x equal to 3 and see what happens. So run. The value of x is 3, so this would be 1/3 plus 1/9 and so on. Value of x equals 3. Number of terms in the sum is 10. And notice this one is approaching 1/2. Run. Value of x equals 3. Number of terms in the sum is equal to 100. And this goes to the value of the sum is 1/2. So 1/3 plus 1/9 and so on. What's going on there? Let's try another one. Run. Value of x pick equal 4. Number of terms in the sum is 100. And this goes to 1/3. So the question, of course, is this sum summing properly what it should be? And we'll investigate that in another video. Okay? Until next time.